Welcome, everybody, to the American Space Museum. I'm Marquette. We're so glad you're with us to stay curious today. Today, we're doing a program about our backyard astronomy theme on Mondays, all about the sun, which is behind me here in a gorgeous uh, 9 different slices of it. And the 10th one's the only way that you can see it in available light with your eyes. Usually I open up our backyard astronomy with the binoculars, but no, do not ever look at the sun with binoculars, okay? Don't ever do that. Don't point hunting rifle sights. Don't use a telescope of any kind. I'll show you a safe way to look at the sun with telescopes. But why are we talking about the sun? Because it is peaking out in an 11-year cycle of highs and lows, about 11 years between each of the highs or each of the lows. And right now, the sun is warmer than it's ever been recorded in human history. And I think you saw something in the news that the Earth has the highest temperature ever recorded in human history, since we had thermometers to measure it. We don't know really what it was like 3,000 years ago. We can guess. But point being, sun's hotter, Earth is hotter. Yes, it has to do with our favorite star, and it does have to do with global climate change that human beings are contributing to. But there's a lot of variables from this star, and I think when you see what NASA's doing with that Living with the Star program, a program that's called Living with the Star, LWS, NASA's scientific program to study all aspects of the sun, been going on for 2 decades. Stay curious and you'll learn more about that, because I'll bet you didn't know about that. So this is Monday, August 12th. There's lightning in the air. That means I'm hearing thunder in my background here behind me. And got Logan Cope on the board as Marty continues his vacation. I'm going on vacation this Thursday, Friday, and next Monday and Tuesday. And we will see if we're going to air some repeat shows. We certainly ought to. We have over 600 of them to choose from. So I'll let Marty decide that as we all at the museum are mourning the loss of our leader, Karen Conklin, who passed away Sunday morning. And if I dwell on it too long, I'll start to cry. But because I cried a lot yesterday and today, I'm just taking a celebratory attitude about Karen's wonderful life. Many of you that watched our Stay Curious program have made comments on our Facebook page, and she named Stay Curious. Okay, and I'll talk Wednesday about my personal thoughts and some tributes to this wonderful earthling that died of lung cancer just 3 months after it was diagnosed. And we're going to miss her forever. There are some plans in the works with a memorial at the funeral home August 31st. That's a Saturday at North Brevard Funeral Home. And then we will do something with her husband's permission, Mark, and I talked to him and he's on board with, we definitely have to have a celebration of Karen's life here at the museum. So that's about all I can say about it without getting too emotional about it. She was like a big sister to me, and I'll never ever forget what she's done to change my life. And then I would not be talking to you today was it not for Karen. Let me compose myself here just a minute. That going to talk about the sun, and like I said, appropriate time, because the sun is just doing all kinds of crazy stuff right now, and to keep up with it, crazy stuff from it's covered with spots. Okay, there's a little black spot on the sun today, and there's dozens of them. And I'm going to show you what the sun looks like today, very safely. Do not ever look at it without knowing what you're doing. And then aurora borealis and australis in the northern and southern hemispheres are just pouring in as we're going through what they call a coronal mass ejection, CME, of debris actually coming off the sun. And to keep up with it, spaceweather.com is your best source for that. And that's my homepage. They also post beautiful landscape pictures of astrophotography and so forth, such as planet conjunctions and moon against this or that and the other. So I'm going to put up my smart tablet here that I meant to try to do beforehand, but I didn't. And making some notes on a busy Monday today. Tuesday, we're going to have um, Terry White will be here talking about his experience in the Vomit Comet. So if you've been on the Vomit Comet, let us know about it. Of course, you know that's the C-130 that goes through parabolic arcs to mimic weightlessness. And Terry said he'd really like to talk about that because he had to fly some equipment up there to see how it reacted to zero G. So look forward to that. And then we will talk about Karen on Wednesday. Hi, Dean Babcock. Hello, Carlton. Yep, we're getting hit with storms here right now. And William Whiting is sending their love to the family of Karen Conklin. And Tom Usiak, thank you for your thoughts and prayers for our museum and Karen. And hello there, Cliff Watson. And he says, yes, I cried too. And yeah, it's I can't think too much about it or I will start crying because it's just 48 hours away. We really thought Karen was battling cancer pretty good and would be around at least, half a year or so. But this, goddamn cancer is all you can say. It's just we all know somebody in our lives that have passed away from it. And with me, it's my little brother who died almost 10 years ago. So, thank you all for your comments there. Cliff says the pictures that people post from Tasmania of the aurora are fantastic. Thanks for mentioning that, Cliff. I saw one and almost pulled it off. My arse hat here that came off of Cliff Watson's head onto mine is actually the Australian Research and Space Foundation or exploration. All right, can't make this stuff up. You Aussies call your NASA arse. So I love it. Thank you, Cliff. Love the hat. Still got your DNA on it, buddy. I won't wash it. So, well, let's learn about you're going to be blown away about some stuff that I discovered doing this little put together, this program on the sun. Of course, I know a lot about the sun because I've been photographing it safely and looking at it for over 50 years of my life. But I did not know that NASA had a Living with a Star program, an official program that's been going on for 20 years. It's a scientific study of all aspects connected with the Sun-Earth system that directly affect life and society. LWS is cross-cutting initiative with goals and objectives relevant to NASA's exploration initiative, as well as NASA's strategic enterprises. Now, these names of these things don't mean a lot to you unless you tie the spacecraft or what they're doing with it. But the exploration initiative is just that, wanting to explore the solar system. And NASA strategic enterprises is how we're going to do that. The LWS studies include the sun, space weather, explorers program, the magnetosphere, which is the magnetic energy that is like lines of arcs, like you see in a magnet with showing you the poles with iron filings. What I'm trying to say, the old school grade iron filings, and you put a magnet and you see how the poles attract each, and then a kind of a circle evolves as others are trying to connect. How do we live with this star? Solar eclipses are also a big part of it. And the objectives are to focus on the relationship with space science, earth science, human exploration and development, and aeronautics and space transportation. After all, if we understand the sun and how materials are degraded by the sun, solar rays, then we can build better spacecraft. Have you ever noticed at signs in the window, the first color to fade out is red? And red is at a wavelength of light that the sun's light just literally fries it, wipes it out. So the uh, so let's look a little bit as we go to living with a star, but also we got to live with the moon. Okay, and I was looking up here. The moon is so to talk like an astronomer and to understand, is it going to be a good night to see uh, the Great Globular Cluster of Hercules or not? And well, it's be pretty good, but not as good as it'd be 4 days ago because the moon is 9 days old. Okay, no, it's not 9 days old. It's 7.5 days old. It's first quarter moon basically, and that's the seven right there in the sky. All right, this weekend it's going to inch towards full phase, and as I have an app for that called Phases of the Moon, I'm going to go full moon is exactly on Monday, a week from today. All right, the moon will rise at 8:16, but Sunday and Saturday when the moon rises at 6:50, and Sunday it rises at 7:36. That's when you're gonna want to take your photos of the moon rising over different areas of the sky and so forth. So that's how you talk like an astronomer. The moon is 7.5 days old. So we had a knock at the door, Logan. Something important? Okay. All right. We're not on fire or anything flooding or anything like that going on. Okay. Well, this is from that website called Space Weather, and right there is the sun today. All right, this is what it looks like. Now, there is a safe way to look at the sun, and if you use your head a little bit and say, how did I look at the sun back in April? Okay, well, with the glasses, right? The solar filter glasses, and those work all the time, not just for a solar eclipse. So hopefully you saved them. If you don't know if you did, go into the kitchen, get into the junk drawer, start looking in the back there, and you'll find those solar glasses. And you'll be able to see these two giant. So these are there right now. Now, I'm not recommending this, but if when the sun in the evening sets, you can see some of these naked eye sunspots through the haze or the refractive layer that lasts 10 degrees of the down to the horizon. And if you hold your arm out at arm's length, that's 10 degrees, your fist right there. If you go 20 degrees to high, it might be a little bit brighter, but watch that 10 degrees. You're looking through the about 1,000 miles of Earth's atmosphere instead of directly overhead, looking through about 80, and it dims it, and you can see these naked eye sunspots. And then start watching movies. And when you see sci-fi movies or other movies where the sun is really big, I mean, sometimes there's sunspots on them. Yes, King of Pain lyrics, King of Pain by the Police. There's a little black spot on the sun today. That's my soul up there, is what the refrain is. It's the same old thing as yesterday. That's my soul up there. And there's a little black cat caught in a high tree top. There's a flagpole rag and the wind won't stop. There's a little black spot on the sun today. And that's taking you back to the 80s there, Logan. You familiar with that song or even the group The Police? Our intern from Eastern Florida State College is shaking his head. You need to go check out some of The Police, okay? That is a artist named Sting is the lead singer there. He's one of these, he only needs a one word name like Madonna and Elvis and all that. So, but I'll bet you've heard the song. And though it's not called Little Black Spot, it's actually called King of Pain lyrics. So, well, looking at the sun here, is this the next one I put? No, this, yeah, we've got them. So here is a safe way to look at the sun with those solar glasses, okay? By the way, you see the Earth to scale right there? Well, we got some monster sunspots there. All these little ones like that, that's bigger than the Earth. That's about the size of the Earth right there. What caused them? Why there's so many? We're going to tell you about here in just a second. Those glasses there are good to look at the sun with, and you'll be amazed what you can see. Now, I also want to point out something as we're looking at the sun, Logan, that you notice how the edges are darker and it's brighter in the very center, okay? What's causing that? Let's think about that a minute. Well, first you got to think about how big is the sun, and it's 800,000 miles across. Coincidentally, the Earth is just a little under 8,000 miles across. All right, so it's 100 times bigger than us. All right, and it's about 100 million miles away, 93 million miles away. And at that distance, the moon, that's 2,000 miles across, one fourth our size, covers the sun exactly. A complete coincidence that several million years from now, the moon will be too far away and you won't see the corona on eclipse. But anyway, just think for a minute. What if the sun is a ball almost 1 million miles across, 800,000? Okay, and there's a physics of light playing here. All right, why the center is bright and the edges are dim. And I'll share that with you. Maybe someone will figure that out. It's a simple equation there, Steve Jokums, and I bet he knows it. Well, this is my friend in Statesboro, North Carolina, Ronnie Sherrill. Talked to Ronnie today. He took these pictures over the weekend of the sun right there. And there is a shot of, actually, I got it in reverse. This is Jonathan Ward, who's also in North Carolina, and I forget the town Jonathan's in. All right, I think it's Fayetteville area there, but not too far from Statesville, great state of North Carolina. And our friend Jonathan Ward is such a Renaissance man. He just got back from being an astronomy cruise director on one of those fabulous cruise ships in Europe. And he gets home and he's doing solar imaging in his backyard. I saw him photographing butterflies. He's a man after my own heart there, Jonathan Ward. You can always find something in your backyard to fascinate you that wasn't even thought about 200 years ago. You got the equipment, so go out and find you a hobby and do it. But that's Jonathan's picture of that. And then with this, what we call visible light. This is how you would see it if you could look at in white light, we call it. Then he took a picture in what is called hydrogen alpha light, where the sun is 99% hydrogen. When you see all the hydrogen, you're looking at the surface and features on there that you can't see in the visible light. All those little dark snake-looking things are actually flames that are licking off the edge. Those are called prominences. See the one at the very top and one at the top left there, 11 o'clock position. Well, those are what are going on the dark areas. Are these leaping off? They're just a little bit cooler, and then you got these light regions where sunspots are that have a lot of electromagnetic energy going on. There is a close-up of a sunspot. They give them names like I showed you back there so that you can figure out what's what. They can talk about them. As we go across the sun, let me go back this way. These objects move from the left side to the right side. Okay, from it, so it's going on what we're looking at here, left to right. So that big spot in the middle is going to be on the edge, and there's one coming around the edge. We also have solar telescopes, thanks to this program of NASA, Living with a Star, that shows us the backside of the sun. And actually, Mars is at a position in the solar system where the Curiosity and Perseverance rovers take daily photos of the sun to check how much dust is in the air, so they see the opacity of their photo, and they see the backside of the sun for now. Talked about the solar cycle. It's been discovered a couple hundred years ago. So we've been through, I think this is cycle number 26, okay, times 11. So it gives you an idea how many years are involved here, almost 300. And this is like a photo on the left combining all of the sunspots for the past month of July. All right, as they trekked across the sun. And then you see the peaks and valleys, and we had a low point about 7 years ago, all right, in the 2017, and now in 2024, we're at a high peak, and it is really cranking out the solar energy. A little bit of physics here. This is why sunspots are dark. You see these convection cells at the bottom? We're going to see pictures of that in a minute, all right? The physics behind this is that's why we go to college, to learn physics. I probably had 3 physics classes on solar physics alone at Ohio State. And so you got a north and a south attraction, and these magnetic lines of plasma are lifting up plasma lines off the surface of the sun. And it's so crazy that it takes 1,000,000 years for one ray of sunlight, so to speak, to go from the core to it being emitted there. The chromosphere is what is photographed, and the corona is the atmosphere around the sun. Just like the Earth has an atmosphere, well, this corona atmosphere goes out to thousands of miles, hundreds of thousands of miles, and it's 1,000,000 degrees hot. Now, the surface of the sun's only around 6,000 degrees. The surface, 6,000 degrees Fahrenheit. But the atmosphere is, 100 times hotter, and we don't know why. Now, see that prominence lifting off there? We're going to talk about a spaceship that was launched 4 years ago today in a beautiful night launch of a Delta Heavy rocket. There's another photograph of the sun taken by, this is so incredible, it doesn't actually look like a electron microscope, like it could be a little bug or eye or something, electron microscope or a ball bearing or something. But no, this is the sun photographed in Jonathan Ward's North Carolina backyard with I'd say probably a $10,000 investment in equipment. It's not that expensive in a way, but then once you invest in it, then you've got the instrument, and it's a special camera and telescope. And the telescope's not that big. You don't need a big telescope. In fact, something like this, seriously, this telescope that I use as a prop, all right, that's about a 2-inch mirror on that thing. That would be an excellent solar telescope, okay, in there, because the sun's so close, it's so bright, and you can see a lot of detail. So, all right, drop my notes there. Let me see who's else watching today. We certainly appreciate it. Oh, there we go. I lost the live chat. There we go, live chat. All right. Yeah, during the solar eclipse, those of us that saw it in April, you could see the flares are very pinkish orange lifting off the sun with your naked eye there briefly during totality. All right, well, I've impressed. Here's another buddy of mine. This is again another wonderful shot by Jonathan Ward in your own backyard. So the Earth is probably, I'm going to say the Earth is probably about this size. I got some, against that. So against that scale, it'd be about like that white area there. What we got going here is that is the heart of this is an active region, and the white areas are where there's actually energy coming up in coronal mass ejections. They're just amazing to watch live. Nick Sedler says, yes, keeping those eclipse glasses to see other events is important. Now, my buddy Ronnie Sherrill, who's in Statesville, North Carolina, I've spent probably hundreds of hours with Ronnie under the stars on the Blue Ridge Parkway in the Smoky Mountains, and we took several trips to the Keys, to the Winter Star Party in February down there. Look at the detail. And he was telling me he's got a telescope and a camera that are a perfect match. And it's sort of like finding the right golf clubs, the right tennis racket. The tools are tools, but once you feel them for your own idiosyncrasies of how you manipulate things. So just an incredible detail there for a backyard astronomer. And here are those, again, the chain that we're seeing across there. You'll be able to see these with those eclipse glasses. And then Ronnie took this close up. Man, that is so cool. Look at the little grains of like oatmeal, and that's what it sort of is. These are cells of material, and all about the size of Texas. Okay, I can't believe the resolution of this, Ronnie. It is really sharp. Of course, the atmosphere has a lot to do with it. It's very clear that day. Any thin layer of clouds would mess that up. So beautiful, beautiful images there. So you can project images with your telescope on a white sheet of paper. And unfortunately, there's no, you see the disk of the sun. I don't see any sunspots on it. Uh, but you got to make sure this does not get hot. All right. The sun is coming in from the top up here. You want to cover up your finder or use the finder as a projector. But I've heard back in the 60s, Logan, that some children played with magnifying glasses and would like burn ants or different things as they would burn things. Of course, I saw this on YouTube or TikTok or something. Not confessing anything there. But yes, the sun is hot. You're looking at a mirror in this telescope, like a shaving mirror that is converging the solar rays like a magnifying glass. And I've even burned up the inside of a telescope or two when I didn't move it quick enough, because the sun moves and that will move inside there. But that's one way to look. And then another better, safer way is to invest in a cover or use an oatmeal box and put paper over it. All right, that works. A very safe way and a very easy way to share with people watching the sun. Living with a star, all right. Bet you didn't know that existed, but it does, and I'm glad to share it with you. Has 4 basic telescopes, 3 active telescopes that are dedicated to the program, and I'm going to talk about each of them. But the first one I'm going to talk about first is a telescope that was a backbone of all solar astronomy in 1973 and 4, and of course that is the Skylab Solar Telescope. That's what the big windmill is for, all right? The power generated by those solar panels is for this telescope, all right? And the telescope took images of the sun through these small telescopes right here. They've got them covered up, all right? Those slide off of it inside. You'll see the control panel. I'll show you that with Ed there. Ed Gibson is 80-some years old, and he was on the last Skylab, and he's one of 3 Skylab astronauts of the 9 still alive, 1 from each. Jack Lausma, who's from Skylab 2? That's Lausma. And from the first one is, he was a doctor, first true doctor to go to space. Think of it later. Nope, Tom Usiak will tell me. Skylab 1, we've got Alan Bean's gone, Owen Garriott's gone, and I don't even have anything that's got Skylab on around me here. So senior moment there, but so important was the Skylab. This is one of the most publicized photographs of the sun ever that was taken on the Skylab 4 mission. This gigantic arc is solar plasma lifting off the sun. And you got the comment? Yes. Thank you, Steve Jokums. Joe Kerwin. Yeah, Kerwin. And you picked up Kerwin there too, right, Logan? Thank you. Joe Kerwin, saw him out at the Space Center during the Astronaut Hall of Fame, and he shared some great stories there. So good to see you there, Steve Jokums. All right, hope you're enjoying these images, but that was one of the greatest photographs ever taken at the time, and it took us another 20 years to equal that. But once again, that's what the windmill's all about. In the center are 3 or 4 telescopes that are being powered up by the windmill of solar panels. And there's Ed Gibson at it, where he's looking at different apparatus there. Look at all the controls just for that solar telescope to give you looks of the sun like you can't see before. And what this is the orange on each edge here is the way that you see the sun with visual light. Each one of these areas is a different spectrum of the sun, yielding a different look because of the different temperatures and being emitted from that area. And I'll explain that here in just a second. The other mission that was seminal, before the great observatories were orbited around the Earth was SOHO. All right, and SOHO is Solar Dynamics Observer. SOHO, Solar Helios, the Sun Observatory, Heliospheric Observatory. That's what SOHO is. Sun Observing Helio Observatory, SOHO. It conked out when it was launched in 1984. Let me get that date right, because going up to rescue it was, and it took pictures like this, SOHO did. All right, just spectacular images. Again, there's approximate size of the Earth. So in the 80s, it finally started doing what Skylab was doing. In 51 E, I think it is. 41E. Where's the SOHO mission there? Oh, I'm trying to find the. There it is. There it is. 51A. That was Gardner on there. Hopefully, I got it on the slide there. 41C. Somebody's going to tell me was the mission right here. 41C. That Pinky Nelson and Gardner is that the other one? 41C. Van Hoften and Nelson did an EVA. They deployed the LDF, but they retrieved the SOHO. They repaired it in the cargo bay there. And Nelson used the MMU, Man Maneuvering Unit, unsuccessfully to try to capture it. And then they captured it the next day with the robotic arm. And there they are repairing it, set it free. And SOHO became one of the most functional satellites in the history of NASA, again, outliving and outperforming 25 years it's into now. All right. And what is that, 83? Yeah, no, it's 84, 1984, April 84. All right. 50 terabytes of knowledge obtained there, taken over 20 million images. All right. It's been through 2 complete solar cycles, the 11-year from top to top. All right, so that's very important. 4,000 comets it's discovered by watching comets crash into the sun. That's something my favorite website, Space Weather, always shows, is the comets going to the sun. And SOHO has a way to occlude the sun, in other words, block it out, and then you can see some of the stars and planets and comets going into it. It's got 300 PhD theses, 6,000 papers published. All right, and 2.5 million commands have been sent to SOHO, with 15 years on ground stations. So, just an incredible knowledge that we've attained from another outperforming NASA the spacecraft built with your tax dollars, just like the Parker Solar Probe. So, who came down here to see the night launch of the Delta Heavy and this Parker Solar Probe? Well, let me tell you about that. The Parker Solar Probe was launched today, August 12th, 2018. All right. So this is its 6th anniversary, and a mission to touch the sun. Now, wait a minute. You can't touch the sun. Well, by golly, in the last 4 years, it has gone within almost 3 million miles of the sun. And it is the fastest object ever built. It has clocked at 430,000 miles an hour, which for those of you out there is 6/100ths of the speed of light. That's its insignia. There's the launch by Carlton Bailey. Thank you for sharing that, CB. What a powerful sight that they've retired these silos, farm silos looking of a rocket. There's Carlton's photo of the Parker Solar Probe emblem on the side of the fairing. It's inside of there. All right, again, just what a beautiful night launch it was. And went to, there is the illustration of what it looks like. It has on the that big end there, it points towards the sun. It's basically a heat shield, um, and some of the thermal protection system of the shuttle went into that. Um, it's the first spacecraft to fly into the low corona. All right, and it's assessing the structure and dynamics of the sun coronal plasma and magnetic field. Yes, Logan, we've got a question.
Carlton is saying Soho went up on December 1995 on an Atlas rocket.
All right. Thank you, Carlton. I didn't know if it was a Delta or an Atlas, but it was launched in oh, yeah, Soho he's talking about. Yeah, he's talking. Yeah, thank you. Soho was launched in December 95, and that don't jive there, Carlton, because they rescued it in 84, 11 years earlier. So, um, that is according to Carltonpedia there. So, but thank you, Carlton, for these beautiful photographs, and he's thank you for your help here and helping us stay curious. There's CB's awesome streak shot that he took. I know that was August 12th, 6 years or 4 years ago, and let's see, launched at 2018, all right, 6 years ago, named after Eugene Newman Parker, a professor emeritus at the University of Chicago. University of Chicago is a big astronomy college. Parker got to see the launch at age 92, I think. He died in 2024 at age, no, he died in 2020, I believe, a couple years after the launch there. A memory card contains the names. Let me show the spacecraft here. Contains your name, probably Steve Jokums, maybe Dave Stanges, probably Dean Babcock put his name on a plaque that's mounted on the high gain antenna. A memory card contains over 1 million names in there, and mine's on there. So it's protected from the extreme heat and radiation. It actually goes way out past Venus. Took some really cool pictures of Venus going by it, piercing the clouds a little bit. But it's going very fast, so it doesn't. The degree of clarity of some of the pictures is not what you'd think. All right, like this is what I photographed from it that is taking, and you're seeing plasma coming off of the sun, and here is a prominence that looks like a puffy cloud going off of there. So uh, uh, all right, I am confused there. You're all straightening me out. Yes, I got Solar Max confused with Soho. And thank you, Carlton. Steve Jokums is straightening me out there, and Carlton too. Yeah, they had the Solar Max mission, is in Soho was another one. So um, my error there of not doing my proper research there, guys. I added them at the last minute. I was just going to keep the three satellites together. So that's my excuse, and I'm sticking to it. But yeah, thank you, guys. Solar Dynamics Observatory. All right, I don't know when that was launched, unless my notes say it here. Oh, I do. February 2010. This is part of the Living with the Star program. It is the most serious solar observatory ever put in space. It took these beautiful pictures behind me here that I'm going to explain in just a second. And there's its logo. It had the goal to understand the influence of the sun on the Earth and the near-Earth space by studying the solar atmosphere on small scales of space and time in many wavelengths simultaneously. And what does wavelengths mean? Well, you can't see radio wavelengths, okay? You understand that. You can't see microwave wavelengths, but you know what they do when you put popcorn in a microwave oven, all right? You can't see gamma rays that are going through the universe, but you can see the visual on the side there. Now, what would be green, these green here, is probably atoms that are about 11 million degrees hot, as opposed to the visual is half of that, about 6,000 degrees. It's not even half, it's 100 less. So you go from the hotter or the cooler things are, they have a signature because the atoms in that material are going slower if it's colder or faster if it's hotter. And that energy is emitted in various forms here. Like I know this is calcium in here that my finger's pointing at. Look at how the solar prominence at the top show up very well. You got your hydrogen alphas, the red in there. So you got a variety of wavelengths that the scientists are looking at, and it allows astronomers to track how particles and heat move through the sun's atmosphere. So this is the important solar dynamic observatory. There's what it looks like. It's in a big orbit that goes out to the orbit of Mercury and then back in. So it's been around for 14 years, all right, observing the sun since 2010. And another part of this program is the ESA Cooperative of Europe, the Solar Orbiter. The Solar Orbiter was developed by ESA and NASA and is trying to get detailed measurements of the wind, the solar wind that is streaming off of the sun. And this solar wind takes plasma and atoms off the sun's surface, and they're magnetic, and you're going to see how they hit the earth. They create awesome, awesome things. So then there is this solar orbiter. And then the Van Allen probes were a contribution. They were known as the radiation belt storm probes, but changed to be named after Dr. Van Allen, who discovered on the first Explorer 1 satellite, America's first satellite, discovered that around the Earth are these belts of radiation called the named after him. They were radioactive, if you will. Yes, if you hung out inside of them for a while, it'd be like getting a dose of thousands of X-rays. But all the Apollo spacecrafts passed through them. It only took them about an hour or so to get through them, and no damage done. But low Earth orbit space stations are inside the inner belt of the Van Allen belts are about 1,000 miles up, and then most of it is 12 to 25,000 miles, reaching about an eighth of the way to the moon. So as you see, they're driven by the electromagnetic energy that's created by the Earth spinning and our molten core, creating a magnetic field at the poles. The stuff is drawn in, and the greatest solar observatory now in the world is called the NEU, and it is up in on the I think NEU is the name of a politician. There's a 30-year project to build this up on Mauna Kea in Hawaii. All right. And it has taken the most incredible images ever of the sun. That's the observatory there. You see the size of the Earth. Excuse me. I think that's 10,000 miles. So the Earth is about 8,000 miles. This is basically a trough on the sun taken by this telescope. Now, why can't the orbiting telescopes around the sun take better pictures? Because they're moving so fast that the shutter speed, so to speak, can't be done, even though it's the sun. And then, of course, they're compromised by the optics that are on that spacecraft. This is a 30-inch telescope, I believe, that's huge. I think it might be 30 feet. That's huge, pulling in a lot of detail. And here is the closest photograph ever taken of the sun. If that doesn't look like oatmeal boiling or cream of wheat, but each one of these little kernels is the size of the state of Texas. All right. So we're looking at about 20,000 miles square here. This would definitely go from like Europe to Hawaii, maybe in distance there. But the light areas, as you look at, there's a distinctly white areas sticking up there, and that's the electromagnetic energy pulses they think coming up from the center of the sun there. So this is a boiling thing going on here, and that's an incredible image. And as the sun is so active, shedding stuff off, that the Earth catches it, all planets catch it. In fact, there are aurora on Jupiter and Saturn, all right, because they have magnetic fields. Mars does not have a magnetic field, so there's no aurora there. And Mercury is the same way. But you get the idea. We are a volatile situation with our sun. And when the sun emits a coronal mass ejection like that solar flare is, if it could be shed off, on any area around the sun there, and not hit us, okay? Or it can hit us, and once in a while they do. We had some electrical problems back in when was that? Back in July, I think, or June was a big outburst, and we could have more. Now, as I look at the sun here, I wanted to tell you, why is the sun darker on the edge and brighter in the center, as this image depicts accurately? Well, it's called the inverse square law. All right, the center, if the sun is 800,000 miles across, that center of the sun, all right, is 400,000 miles closer to Earth than the edge. Follow me? If you just think about a rubber ball, in the front of the rubber ball in front of your face, okay, your nose right here, and the side of it is over here. It's about 4 inches further, all right, or whatever. So the center of the sun is closer to the Earth by 400,000 miles. That is a long distance with a bright object that creates what we call the inverse square law. So if you have a value in the center of the sun of 1, you would think you double that distance and you would have the value would be 1/2 as bright. No. If you double the distance of an object that its brightness is 1, and you think that if it's 100 feet away and you do 200 feet, you think, oh, well, that'll be half the distance. That'll be half as bright. No, it's 1/4 as bright. That's the strange thing about light, called the inverse square law, that it loses 1/4 of its brightness in those increments of doubling. So that's why the sides are always darker than the center. They're further away, and therefore the light is just that much dimmer. You can get forecasts. In fact, this is a forecast I just pulled off an hour ago, a 30-minute forecast of the pole. This is the South Pole, all right? And Cliff Watson is down there on Australia, over here where they were having some great aurora. He's on the Pomona east side of Australia, of course. And then look at America, North America there. Now, tonight, this will dip down, and there's predictions to be seen aurora in the higher latitudes. And this was up in Minnesota last night. Eden Prairie. No, this is Middleton, Wisconsin, by the way, is what this is. This is Middleton, Wisconsin. Look at that horizon there. There's the Big Dipper. I see the bowl of the Big Dipper right there in the upper left, right in the aurora there. Different colors say what kind of gases are being ionized. These are actual particles from the sun interacting with the Earth's atmosphere as they pour in. It's like a neon tube. This was in Middleton, Wisconsin. Okay, just a beautiful. They could take so many. This is coming right down on top of you. Crazy, isn't it? And then Hollis, North Carolina on my mind today. All right, that's from my good friend Gary Studi. That was an aurora he photographed at that big event we had about a month and a half ago on there. So get out and see see if you can see some aurora. You up in Michigan, Dave Stange. We've got Doug Forrest is in LA. He's not going to see aurora. Gary Gerald rarely gets down to Georgia. Manned space, if Mitch is still in Colorado, he could possibly see it. Dean Babcock, Carlton Bailey, William Whiting, Tommy Usiak, Cliff Watson, Dave Stange, Steve J., and Nick Sedler. All of you guys commented about Karen, and we certainly appreciate that. And we'll let you all know what we're going to do here at the museum to honor Karen. So she was always thrilled for me to talk about stargazing. I'll never forget the first time she saw Saturn through one of my telescopes, and she said I about wet my pants. So, but she didn't. So hope that you all enjoyed a little bit of solar energy today. We get those eclipse glasses out, take a look at the sun as it's going down tonight or coming up in the morning when it's not so hot, and I guarantee you that you will see some of those sunspots on there. So thank you all for watching. Tomorrow we got Terry White coming in here, and Terry's going to talk about, he of course is the NASA lead garage mechanic for the orbital processing facilities of the shuttle eras. And Terry will be here to talk about the Vomit Comet. All right. And then Wednesday, we'll do a tribute to the beautiful Karen Conklin. So until tomorrow, I'm Mark Marquette saying I'm thanking you for watching today. Thank you, Logan, for a great program. And get on in our museum, because I can't wait to shake your hand and bridge the space between us.